Now let's take a look at a different kind of proof of angle relationship, not angle but segment relationships. This is not a theorem, but it gives us an idea of how to use the theorems and how to use the properties, definitions, and postulates to come up with proofs. We have this line segment VY. It's divided into three different segments. We have a W and an X. Then we're told that X is the midpoint of WY. We're also told that W is the midpoint of VX. And then they want us to prove that segment WY is congruent to segment VX. Okay? Now, we have our givens right here, so let's put them down. Statement number 1. X is midpoint, and I'm going to abbreviate, of WY. What's our reason? They told me so. It was given. Statement number 2. W is midpoint of VX. Given. Okay? Now, what can we say about this whole thing because X is the midpoint of WY? Well, because it is the midpoint, we know that WX equals XY. The measurement of WX equals XY. 3Y, definition of midpoint. Okay? Pretty simple. How about because of this one? W is the midpoint of VX. What can we say? We can say that VW equals WX. And again, why? Definition of midpoint. You have to know those definitions. You don't know the definitions, you're going to get in trouble pretty quick. So there's our first 4 properties. Well, what do we got here? We've got this right here and this right here. So what can we say about VW and XY? 5. VW equals XY. Why? Transitive property. Okay? All right? All right? So VW equals this. Okay? 6. We can come in here and we can say that XY plus WX equals WX plus VW. Okay? And all we've done here is done what? We've just simply used the addition property. All right? On this right here. That's all we've done. Okay? Now then, our 7th statement, we can come in and what do we know? XY plus WX. Well, XY plus WX equals what? XY plus WX equals WY. Because of what? SAP. Segment addition postulate. Well, what can we say about the other side? WX plus VW equals what? VX. Okay? Why? Segment addition postulate. Okay? What do we know about XY and WX and WX and VW? Well, they're equal to each other, aren't they? And if these two are equal to each other, then anything they equal is equal to itself, okay? So number 9 is going to be due to substitution. And then number 10, we simply say segment WY is now congruent to segment VX, Y. Definition of what? Congruent segments. Alright? Notice we started with our givens. X is a midpoint. W is a midpoint. Then we said because X is a midpoint, what do we know? WX is congruent to XY. Definition of midpoint. And because W is the midpoint of VX, then we know that VW is equal to WX, definition of midpoint. These are equal. Okay, number 5. Because of that, they have a common WX. We know that this is equal to this by the transitive property. Then we just simply did addition. Okay? We took XY and VW, this one right here, and we just simply added XW to it. Addition property. Then we know that XY plus WX added together equal WY. Why? Segment addition postulate. This piece of the segment and this piece of the segment equal this piece. And by the same, right here, this piece plus this piece equals this piece. Okay? Segment addition postulate. Well, these two are equal to each other, and because they're equal to each other, then anything they're equal to is equal. So simply by the substitution, we know that WY is equal to VX. Therefore, if they're equal, then those segments are congruent by definition of the congruent segments. Okay? That's how you use this stuff to prove segment relationships. Welcome to geometry.